All right, so our notes for today are 1.2 on simple random sampling. And we have these three goals: distinguishing census versus simple random sample. Secondly, recognizing best practices for obtaining a representative sample. And then thirdly, we're actually going to bypass the random number table for today. And within this lesson, we're going to practice using a random number generator. So that's a little bit more relevant than the random number tables today. So first, we're talking about census, sampling, and experimentation. So those are just three ways to collect the data. First of all is census, which is obtaining information for the entire population of interest. So most often we're familiar with the U.S. Census, which happens every 10 years, and it's actually a pretty laborsome project. It takes lots of time and lots of money to try and collect demographic information from everyone in the entire country. So the population of interest in that case would be everyone in the U.S. But I could also do something and consider a census of all students of School of the Arts. That would be if I asked every single person and everyone responded to my survey. That would be a census. Sampling, on the other hand, is a method for obtaining information about a population by taking a sample from the population. Inferential or descriptive at that point? Inferential. If you took a sample and then you made a projection about the whole population, you're trying to understand the population better. That would be linked with inferential statistics. Good. Experimentation then. An experimentation is a controlled study in which the researcher attempts to understand cause and effect relationships. Based on the analysis, the researcher draws a conclusion. Good. About whether the treatment, aka the independent variable, had a causal effect on the dependent variable. I basically summarized that whole section from yesterday in that little couple of sentences, just to put it into context and connect it with the census, sampling, and experimentation methods for collecting data. So then the last piece here is representative sample, and that is when you have a representative sample that reflects as closely as possible the relevant characteristics of the population under consideration. Representative sample is key to being able to make a reliable inference about a population. So that's going to come up over and over again. We want our sample to be representative of the entire population in order to make a valid inference. Feel free to take additional side notes as I'm talking. I might not write down everything. I don't want you to get in the habit of only writing down what goes in the blanks, because something I say might also, like when you go back and look at the notes, it might help you, oh yeah, she said this, but it's going to be different for different people. So feel free to make side notes as I'm saying things that are not on the paper. Okay, example, to best understand responses of the entire class, which would be a representative sample. Circle the best answer. There's only one. That means 3 are wrong. Sample responses from all of the gentlemen in the class. Would that be a representative sample of the whole class? Nope. What about sample responses from just the vocalists in the class? Nope. Sample all student responses just from Fairfield High School? Nope. We have 12 different school districts represented in our population here at School of the Arts. What about sampling half of the student responses at random? That's the only one left, so it's got to be it. Yes. Random sampling is a way to get a representative sample. So one particular type of random sampling is called simple random sampling. Okay, that's when formal definition says a sampling procedure for which each possible sample of a given size is equally likely to be the one obtained. So simple random sampling is where literally I give everyone a number in the class and I put them in a bowl and I pull out numbers and sample people at random based on the number that I chose. It's just, I give everybody at School of the Arts, they're listed by a number, put all the numbers into a random number generator that generates a random number between 1 and 167. Let's say that's how many students we have. And the number 12 pops out, and you're number 12. So you're part of my survey. Okay? Just very random, simple random sampling. Simple random sample then, it's just the noun that goes with the verb, is a sample obtained by a simple random sampling. So the results of my simple random sampling would be a group of 30 students. Those 30 students are my simple random sample. Good question. These two should be indented. I'll fix that for next time. These are two types of simple random sampling. One is without replacement, with replacement, SRSW, where a member of a population, we put the number back in the bowl to be chosen again. They can be chosen more than once. So more than once is the distinguishing characteristic there. Versus simple random sampling without replacement, SRS. A member of the population can be selected at most once. So I'm gonna took the bowl, Mendez took the name out and said, "What's your major, Mendez?" What's your major? Dance. Okay. I set Mendez's number aside, and then I reach in and grab another one. Allie, what's your major? Dance. Oh, happens to be dance also. Okay. And then I set it aside. I can't choose Allie again because I took the number out. It is not replaced back into the bowl. All right, let's take a look at an example. See how it applies. Can you read that for us, please? Anybody volunteer to read? Grayson, thanks.
Sampling Oklahoma state officials as reported by World Olympic. How do you say that? The top 5 state officials of Oklahoma are as shown in Table 1.2. Consider the 5 officials a population of interest. Table 1.2, 5 top Oklahoma state officials: governor, lieutenant governor, secretary of state, attorney general, treasurer.
Thank you. Great. So part A just says list the possible samples without replacement of 2 officials from this population of 5 officials. This population is 5. That's unrealistic. We typically work with much larger populations, and the sample size is 2. So that's a very small sample size as well. That's just for the purpose of us working out these concepts in a way that we can do in a small period of time, just so we can understand the concept. So for this question, 2 members from these state officials, we could start with, and we want to go in a strategic pattern here. I'm going to start with the first two letters, GL. So in that sample, I have the governor and the lieutenant governor, randomly. And then my next two, I'm just going to stick with G and pair it with all the other letters in order, going down the list. So GS, and then GA, and then GT. Notice it did say that we're using without replacement, so I can't have any repetition. So I'm putting G aside now in terms of what I can have for my other pairings here. So I could have lieutenant governor. I'm just going to stick with L and do the same thing. Starting with L and go down to S. Could I do LG? Could I go back up? No, because I already have that combination. That would be a repeat. Can't have this. So LS and then LA and then LT. And then no more L's. So I do the same with S. So it's going to be S what? SA and then what? ST, good. And then no more S's, so just one more AT, that's it. And I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Got all 10. Next it says describe a method for obtaining a simple random sample of 2 officials from this population of 5 officials. Just like we described earlier, we could say, we could write each letter on a paper and draw 2 at random. That's just a super simple way to do it. Since there's only 5, it's not that hard to just write them all on a piece of paper, G, L, right? And then toss them in a bowl and draw 2. Now enter probability onto the scene. We have, for the sampling method described in part B, what are the chances that any particular sample of 2 officials will be the one selected? What are the chances? What is the probability? How many are there again? So what is the probability of choosing any one of these? That's right, 1 out of 10. Any one of these has the same likelihood. Remember that definition on the front? We had equally likely as the definition of simple random sampling. All right, just for the sake of time, I'm going to keep on going, and then I'm going to come back to that second part and redo it using a larger sample size. We're going to move on, though, to best practices for simple random sampling. Use a representative sample. Secondly, be skeptical. That's basically what that says. Whenever you hear on the news the results of the survey were, listen carefully to the details of the study. Was the sample surveyed representative of the population? They may or may not give that answer. They may or may not give the details of where they even got their information. In those cases, you just want to hold that information loosely. If I'm really going to go out there and tell my friends, I heard that 50%, whatever, 60% of people, blah, blah, blah. I want to make sure that what I'm repeating from what I heard is coming from a good source. Does that make sense? Just being critical statisticians here. All right, last section, sources of bias in sample surveys. That is why everyone has bias. right? We all are kind of born with some biases. We have different personalities. We have different experiences. And the definition of bias isn't bad. It just says a predisposition to one particular outcome over another. If I'm watching a Bengals game, I want the outcome to be a Bengals win every time. So, here are some different examples of biases. First of all, the sample size. Your sample size should be at least 25 for our purposes. There is a whole process you can go through to determine what the sample size needs to be representative. Like if we're talking about representing the entire country, 25 isn't a large enough sample. But for our semester, 25, we're going to stick with that number. We're not going to get to that whole strategy of calculating the sample size specific to a particular population. So 25 is the key number to remember. Another type of bias is non-response. Non-response bias is when non-responders from a sample differ in a meaningful way to responders. This is where that opener comes in. So the non-responders, people who choose not to respond to the Butler Tech surveys, is there something that they all have in common? Or is it just kind of random? Upon my observation today, it feels really random. So I don't know that there is a common thread there. But if there was, we would be dealing with non-response bias. The next type is voluntary response. Occurs when the sample members are self-selected, volunteers, as in voluntary samples. Very similar to the previous one. This is when maybe on your social media feed, you see a survey and you're like, yes, I want to take that survey. You volunteered to take that survey. You're walking along and someone's got a clipboard and asks you to take a survey. You don't have to take that survey. That's voluntary response. People who don't want to take that survey may have a strong opinion and or may not care. Maybe that's more likely. They don't care about whatever that survey is about. But the people who feel, most often, the people who really are think positively towards that, whatever the survey is about, they're the most likely to respond. Do you see how that would be a totally biased set of information? So it looks like people like that thing more than they truly do if we took just a random sample, a truly random sample. And convenient sampling is another type of bias, a method adopted by researchers where they collect market research data from a conveniently available pool of respondents. So let's say Ganesh went viral on TikTok and has these 1.2 million followers and does a TikTok putting out a little quick survey of what do you think of my music dance TikToks. Your TikTok music dances. So when Ganesh does that, the people who respond are his followers. What are they going to say? Yes. Do they like his TikTok dances? Everyone loves Ganesh's his 1.2 million followers love his TikTok dances, or why would they be following him, right? That's called convenient sampling. Better way to do that would be to have Ganesh go ahead and do his TikTok dance for a random sample of people, and then let people decide, right? Not just his followers. So that's where convenient sampling comes into play. Last one is undercoverage. So occurs when some parts of your research population are not adequately represented. juniors taking stats are a small percentage, right? So you are not adequately represented in my stats classes. If I decided to use all my stats classes to represent the opinions of SOA, juniors would have an under coverage bias. Does that make sense? Excellent. All right, so those are our notes for today.